Hello everyone, let's start with a new topic today that is introduction to PCB design. In PCB design, there are few steps to be followed which is very important. So on the screen if you see a block diagram, the first step is the schematic design where you will design the circuit. The second step is to assign footprint to schematic. So in this step you will assign the footprint to that particular component. The third step is to uh, lay out the PCB, that is PCB layout. Fourth step is once you have finished the PCB design, then you have to give it to the PCB manufacturer. The fifth step is to assemble the component and then solder it. The final step is to test the PCB whether it is functioning properly. There are lots of tests involved in this PCB to be taken care of. So once you are done with the PCB, you can then upload the code. So this was the PCB design flow. Now let's look at what is exactly the PCB. This is the board which we will design. At the end of this course, you will be able to design this type of PCB. Let's look at what exactly the PCB is. PCB stands for printed circuit board, where the circuit or schematic is embedded onto a single board. Or we can say that the electronic components are connected with respect to the circuit so that it looks compact, efficient, and usable to work. The PCB consists of a non-conductor board with a copper track, pads, solder marks, wires, seal screen, and mounting holes. The size and complexity of a PCB depends on the circuit and the component used. Basically, there are different types of PCBs. These PCBs are classified into different types like single-sided PCB. In single-sided PCB, the components are placed on one side or you can say on one layer and the copper track is on another side or another layer. But in case of double-sided PCB, the copper track is present on both the up and down layer to make the connection. In multi-layer PCB, there are more than two layers of copper which are connected with the help of via and dia. We will see this multi-layer PCB in detail in upcoming session. These PCBs are compact and complex. As I told you, there are important terms in PCB which needs to be understood. Let's look at this one by one. So if you see on the screen, you will see at the right side, this is a PCB. It is a multi-layered PCB. So if you see the green part, this part is the top layer and the light green which you see is the copper track. This is second layer, that is middle layer 1, middle layer 2, middle layer 3, middle layer 4. So if you see the middle layer 2 is ground, this is like ground, and if you see this orange part, this is wire. So the connection between these is made with the help of this wire. This is a through hole. So at the bottom side also, if you see this layer, this part is touching the top part. So this is a through hole component. So this way we have this multi-layered PCB where we have the ground and the VCC in between the PCB in different layers. Let's look at this layer. What is exactly layer? The PCB has different layer onto which the circuit is built. Now second is footprint. It defines the size and dimension of the component which will be mounted on to the PCB. So let's look at this picture at the extreme left top. This J1, this is a DC jack. So the white outline which you see, so the DC jack will fit exactly at this point, covering this white line. You can also see the USB. So it has the white light at the bottom. So the component exactly fit at that particular point. So it helps, footprint helps in laying the like component exactly at that place. So this is footprint. Now the third is the seal screen. Marking and name of the component and other graphics. So if you see the J1, U2, C16, C17, like the mainboard version 1.0, this is a seal screen. Board has a layer of seal screen also. Now next is the solder marks. These are the colors used on the different layer of PCB so that it does not get oxidized. So if you see the green part, the dark green part at this point, this is a seal screen with green color. Okay. Next is the pad. Pad is where there are different types of pad like this DC jack which has a pad in oval shape. This is a pad. The C16 capacitor has pads to like at this point and this point. These are used to help in soldering the component. Pads are of different sizes and shape where the component pins or terminals are soldered, whether it may be through hole or it may be SMD. Next is track. So you can observe the track in the picture like the track green part is going from one point to one pad to different pad to connect the component according to the circuit. Now we have the mounting hole. It's not on this PCB. I can show you exactly how to do these mounting holes and how it exactly looks in the later section. But basically, mounting holes are used to in PCB to hold somewhere in the enclosure or to fix that PCB properly onto some uh, mechanical things. So next is wire. So you may know we use wires in multi-layer PCB as I discussed in later session. Used to make connection in a different layers. So wire comes in different layers in connectivity. Now we hardly looked at this layers of the PCB. Next, we will move to the component, the types of different component used in electronics. So based on the pads used in PCB, where we solder the component, like they are classified as a through-hole component or SMD component. SMD stands for surface mount device. So in the first picture, if you see, this is a preset which is like mounted on this PCB, but the pins are like through the came through the port. So this is a through-hole component. At the right side, if you see, this is a SMD component where I've shown the capacitor, which is mounted on one layer, on the top layer, and it is soldered on that pad. So this is a SMD component. So you may have understood the difference between the through-hole component and SMD component. Let's look at the packages available in the this SMD component. If you see this capacitor and this D1 diode has a different size. So this depends on the package which we are choosing. It may also have a different package. For example, this IC has a different package with 5 pins. So there is a standard which follows in this SMD and through-hole component in packaging size. Some of them are listed down, like the passive component like resistor have packaging ranging from 2920 to 01005, where 2920 is the like a biggest, and then it will go down and 01005 is the smallest one. So one can find the complete dimension of the particular component selected from the data sheet. So it is exactly important, extremely important to refer the data sheet. Make sure to select the appropriate dimension of the component while designing this PCB. If you look at this SMD package like 0805, in millimeter, the dimensions are like 2.0 cross 1.3. If you compare it with like 0402, it is like small, 1 into 1 cross 0.5. So like in resistor and capacitor, we have this type of dimension, but for in transistor, we have packages like SOT, which stand for small outline transistor, and for IC, we have like SOP, TQFP, BGA. We will get to know this in detail in the later